Question number 9. In parallelogram ABCD, diagonals AC and BD intersect at E. Which statement does not prove parallelogram ABCD is a rhombus? All right, well, first thing I always want to do is draw it out. If there's no picture, I'm going to make a picture. In parallelogram ABCD. So I'm going to draw out a parallelogram A, B, C, D, more or less. Here is my parallelogram. A, B, C, D. Make sure when you're drawing a parallelogram, it goes either all clockwise or counterclockwise. Don't go like how you read a book. You're going to mess it up. That's just naming shapes. You have to go either clockwise or counterclockwise. All right, so, and even if you didn't get that, they talk about diagonals AC. If I said A, B, C, D, that wouldn't be a diagonal. So, diagonal AC, maybe I'll draw this in a different color. Diagonal AC, diagonal BD, they intersect at point E. All right, well, let's zoom in on that. Why are we so far away? All right. Which statement does not prove that it's a rhombus? So if AC was equal to DB. Well, a rhombus, now I'm going to zoom back out again a little bit, coming back and forth so much. A rhombus is a parallelogram, but all of the sides are equal. So here it's a parallelogram, they're all equal. Notice though that my diagonals in a rhombus, just kind of sketching one even, this vertical diagonal and this horizontal diagonal, they look like they're different sizes. So, I mean, you know, maybe I can have a rhombus where the diagonals are the same, but in the one that I just sketched, the two diagonals don't need to be the same. So the fact that I have two diagonals being the same as saying this should prove that it's a rhombus, well, here's a rhombus where the diagonals are not the same. So actually, maybe number 1 is going to be our answer. Let's just check some others and see how we feel about that. Number 2. Oh wait, can I do? That's pretty cool. I can point at number 2 from here. Whoa. Number 2. AB is equal to BC. AB is equal to BC. Well, if AB was equal to BC, I know in a parallelogram, the opposites need to be equal. So if AB is 2 hash marks, that means DC has to be 2 hash marks. And if BC is 2 hash marks, that means AD has to be 2 hash marks, because that's just a property of a parallelogram, is that my opposite sides on a parallelogram are equal. So if I said that AB was equal to BC, these two adjacent sides are equal, well, that means all of the sides are equal. That means that it's a rhombus. So number 2 does prove it's a rhombus. That can't be my answer. Let's see number 3. Number 3, oh, I'm going to kind of cheat on this one. Number 3 says that AC is perpendicular to DB. That's, I mean, it's not really cheating, but it's sort of like you know it or you don't know it. In a rhombus, and you can kind of see by the picture, if you're a rhombus, your diagonals are perpendicular. And in fact, if I have a quadrilateral with perpendicular diagonals that is a parallelogram, by definition, it is a rhombus. So 3 is not my answer. Okay. Number 4. Line segment AC bisects DCB. So that means my diagonal is bisecting one of the angles. If you look in a parallelogram, that's not true. This side looks a little bit smaller than this side. In a rhombus, That sure looks true. And if I start to kind of draw out my quadrilateral family where I have some weird old quadrilateral grandpa up here and it has its children are parallelograms and everything else. Parallelograms kind of splits out into rectangle and rhombus. Well, a rectangle also its angles are not being bisected. Maybe if I draw a thinner rectangle, it makes it a little more obvious that my diagonals are not bisecting the angles. This angle is definitely much bigger than this one. So that's not a property of the rectangle, and therefore it's not a property of the parallelogram. But when you come down and you have this incest and the rhombus and rectangle get together and they make this square, well, I know that my square, the diagonal, cuts my 90-degree angles into two 45-degree angles. That property has to come from one of its parents, and if it doesn't come from parallelogram or rectangle, it's got to come from rhombus, which means that if my diagonals bisect the angles it hits, that proves that it's a rhombus. So, well, or a square, but a square is a rhombus. So 4 also proves it's a rhombus. It looks like number 1 is my correct answer. In parallelogram ABCD, diagonals AC and BD, blah, blah, blah. Which statement does not prove it's a parallelogram? Sorry, that parallelogram ABCD is a rhombus. That would be the fact that if I had the two diagonals are equal, AC and BD, that's not enough to show me that I'm a rhombus. So the correct answer here is indeed number 1.